to do the exercise. So, okay, now started. So, welcome you all in the third day of STC. On the STC is about giving you the hands-on training on the root, the GeoGebra and GNU plotting, and the LaTeX. So I'll take the today's session. Yes, sorry, fourth day. So I'll take you first to the root. We'll complete the root, and then the Ritu ma'am will introduce you some LaTeX from 5 to 6. So today's session is from 2:30 to 6 o'clock. We will take some break also in between. And now I'll introduce you some folder. You can see my folder. Yes, I think yes. This folder I have sent it to you, where I have compiled few exercises for you, and you will today do some hands-on on these exercises. Why I made the exercises for you? Because these exercises for those who are beginner and who should also know how should we work. We should not put every exercise in one folder and saying that, okay, if my name is Hema, then I should say hema.c or print.c. How we should organize our work. This is the root tutorial, the main home folder, inside home folder, I created one folder, the root tutorial, and then I created, saved all the exercises which you have to prepare your own. And I'm clicking, so you have to prepare your work like exercise 1. The exercise 1 should point to this hands-on material which I have given to you. Okay, the exercise 1 is about the scripting. Yesterday we did about on the root terminal, right? The same thing you can do on the scripting. So don't worry if you fail while doing your first program in scripting. But many student have already sent to me all the tutorials which I performed yesterday, and you also performed with me on the terminal. So many students have sent me the assignment in the email. Although I have not asked that you have to send it to the email, you have to send it to the classroom. Okay, although I asked you to, I'll tell you, but please submit your assignment in the classroom. Okay, in the same classroom where we have submitted our installation scripts. Okay, and nice to see that Fatima has sent me, and Fatima is able to compile. Some student, Chitranshi, has also sent me, and a number of students, I could not name those students, but they have tried at least today morning. Everyone has sent. Yesterday, few students have sent. So you can see where we were in the last. We did this. We also filled this, and here I have given to you how you have to do the stack. Few students are done with the stack plot. Stack plot, you have to add some stack class. Okay. Here I want to highlight the canvas. Maybe the student is not knowing what I am doing here. I am doing here C1, divide 1 and 2, where 1 is my column. I don't think so. This is row, right? 1 is my column and second is row. Chanchal, is that clear? It is not row and column? If I
No. Yes, ma'am. We can see next slide.
Yes.
This.
So yesterday, few students. Now you can mute, Chanchal. Yesterday, few students were stuck in here. So you have to understand what I am doing. I should not do 1, 2, 3, 4, and 5. If I want to do some 5 plot in one canvas, I should always divide my column or row. So 1 meaning column and 2 meaning row. So let me explain you. So what I did here, I am on the slide number 36. If you are unable to catch me on this screen, you can download your stuff and please follow me. Okay. So here 1, 2 meaning I am dividing I am putting one column and row 2. So you can see row and column is 1. Can you see this? You understood what I want to say. This is my column. This is the column 1 and row is 2. So always first refer. So if you want that your plot should come in in this like that vertical, you just divide 1 into 2. If you want to 3 plot in the vertical, 1 into 3, 1 into 4, 1 into 5. And if you want to make it a horizontal, 3 into 1, 2 into 1, 4 into 1. So your plot will come 1, 2, 3, 4, 5. Am I audible? Okay, can you hear me now?
Yes, ma'am.
Sorry, there was a power cut today because of the heavy rains here. Uh, okay, so sorry for this inconvenience. We have some issues here. So can you see also my screen? I think yes. Okay. So you understood what now, Chitranshi? Maybe you can solve your issues which you were facing. Okay, you were pointing me today morning that you are facing issues. While many students have asked me this question. So now we will start with this we did yesterday. You can do it on the terminal. Also, you can do it on the script. I would like you to participate in the script. This command is for executing and compiling the script .x, load and compile. Okay. And now we will start with the histogram. I think, can you see the full? Yes, now you can see the full. Okay, so we will start this histogram. So what this says that I created a canvas which has the x dimension 700, y dimension 600, and I'm creating a one dimensional histogram whose name is H1 but title is histo from the Gaussian. 100 is the binning number, minus 3 to 3 is the range, minimum x to maximum x, and I'm filling with the Gaussian of some 100,000 events. Yes, okay, and I want to draw using the script. So yesterday, few student, I will do it in the Ubuntu always, but yes, I also checked. Few students were asking me that they are unable to set the path of this. See, what I did, I also download or install in the C drive. It is automatically going in the C drive for the Windows. Please listen carefully, and uh, it is automatically storing the environment and setting the environment for my root, so I can do wherever I want the scripting. I don't know what you have the issues that you are not able to. If still you have the issues, for time being, maybe you can do in that folder of the C drive, or there is an environmental file. This root that folder. You just go into the bin. There is a this root.sh. Okay, maybe you can copy that bin dot this root dot sh file in the home directory, and you will be able to compile all your program without any error. Okay, I'll follow my all things in this terminal, but the same thing we can do in the root. For getting this terminal, which you can see in the screen on the Ubuntu, this terminal you can get from the cmd command in your Windows machine. Okay, so now I will start my tutorial. What we will do, we will start a histogram. I'll start histogram, and then you also parallelly do that, and we will have some time where you can ask me your previous problems, or the assignment you are not be able to do, I can give you the hints. Okay, so I'll start some for exercises. I am going into that folder. Just I prepared for you, and here I will give you, I'll ask you few other things to do, because these are already script. You will say, oh, ma'am has met for already done for this. So some student has also issues in installing Emacs. So please install in Ubuntu Emacs. This is for Ubuntu users. The Emacs you can use for installing the Emacs, you can use sudo apt-get install space Emacs, or you can also go into here. You can see the software. Can I show you something? The on the soft updater or software updater. Can you see this software updater? You can click it. There you just search Emacs. It will show you the library for Emacs and download, install it. It will ask you the administrative password, which is your login for your system, your laptop. You can give your user login or administrator login. Okay. So here I have already installed Emacs. Emacs is, I find it is very useful, but you can also see that gedit is the default editor. So you can also work with that. Okay. So this was yesterday. This is the print macro. We already did this, but yes, I can. So how you have to compile? I'll just recall you. We should do root minus L. Okay, then that banner will not come, and then this it has a void print macro. This print macro should have the same name. This function should have the same name as your file name. The file name should see dot save in terms of .c format, and you are just printing your statement here. So I'm just doing .x. Please make your notes .x print macro.c. So you can see here first print in root. This you be already done this, but if you want to recall, this is our next class. So I just will make .q to exit the root. I'll close safely before before closing this. I have to save all the files. Now I am in the same folder. I am in the exercise number 2. So I'm just opening this exercise in front of you. Okay. Here I have kept a few things for you. Just for comment part, if you don't want to execute this, it is always coming in red. Here I want to mention you, and it is a very good habit. You do some comments in your script. So comments meaning what this line meaning, what this says, what I am doing here, filling data in histogram in the Gaussian curve, drawing the histograms, coloring the histogram, filling the histogram, setting line width. So this is known as a comment part. Has start from double line, not the hash. In your, I think, LaTeX, you have hash, if I'm correct, or percent. Here you will do double slash for making your script as a comment, so that when anyone other should start, they see and they themselves understand. So why I kept all these scripting for you? Just because you are as a beginner can start and you know how to write it. Okay, if I ask you, okay, you just may prepare your own first, you will be able to, but your T canvas will be here and th1 they will be here. So this is not. So what is the advantage of Emacs editor? Can you see my the cursor? The cursor is on T canvas. If I do it a tab, this tabbing is very good in the Emacs. It is not in very good in the G editor. Can you see? I am using my lower key or upper key, and I am using the tabbing. So the tabbing and the line number, can you see the advantage of this? Can you see the line number? If you face some error, it will say that at this line number, you have this error. So I am on the line number 15. Can you see at the bottom where this file name and then L15? Okay. So this says that I have the issues, or I am facing some error at line number 4, 5, 6, and so on. Then save it. Okay, don't close it. What command yesterday I asked you, that this ampersand. Again, please make your notes. If you are opening your Emacs, you have to consider that ampersand you should keep, so that at the same time you have a terminal, at the same time you can do scripting. Now I am compiling. Again, I am going inside the root by typing root space -L. or root you can also type. Then dot x. Then what is the name of my the exercise number 2, where I am just putting this. I should be in the exercise number 2 folder. Sorry, I am also in the exercise number 1. CD space dot dot. You are coming outside. If you are not familiar with the Linux command, you can use this folder format also. So where I have to go, exercise 2. But then you have to open your root cursor here, terminal here. But it is not good. You have to get familiar with the Linux commands. So cd is going inside, cd space dot dot going outside. Those two commands you remember. Mkdir for making the new directory. Okay, so I'm just going to the exercise number 2. So can you see the my screen? And if there is also a command where I am pwd path. So I am inside my home, Kavita, root tutorial, and for workshop exercises which I sent to it, and I am inside the exercise number 2. And now I'll run the root dot x. The file name is histo one dimensional. So there you just see. Can you see this? So yesterday we did on the terminal. Today I did the same thing. The same thing I wrote there. Where is my? Can you see? This is my script. So I have just opened everything. Here is my script. Here is my histogram, and I can, if I drag and drop, here is my terminal. Okay. So you can change. You can drag, squeeze it. You can extend it, and you can change the color. So changing the color, you have to click on the draw panel and make your red color 3. 3 is a fine. If you want not to do change the attribute here on the draw panel, there is always a good option for you. I'm closing this now. There is an option for you which I have put it as a comment. Can you see this? H1 set fill color. This will fill that histogram. So can I do this here? And can I see if I'm able to do this? So let me do here. I want to change the attributes. Okay. Control Y and then tabbing. Okay, save it, compile again. So it will fill the green color. So K green, K red, K blue, these are the syntax in filling the histogram. So there is no problem if you are not be able to do, don't want to do, or you are not be able to do on this draw panel, or if you forgot, please go into the manual or visit this beautiful slides, and you can also invoke all those attributes in the macro. It is easier to do everything in the macro. Okay, for window user, I would again say, if you are unable to locate your path directory, please do it in the tutorial wala folder and execute some of the examples which I am telling it to you. Okay, but make sure your this histo 1D and that the file name should be the same. And you have to run it in the .c file. Is that clear? Or take the tutorial file there and do the same thing. Okay, so now I'm closing it. Please do parallelly, and I will also help you executing this, explaining all these programs and executing all these program which we have. So now I am page number 41. Okay, here this is a very good thing, I must say. Yesterday I explained you how to generate the Gaussian. Here you have also possibilities to draw your n number of functions or distribution which are statistical distributions. Let's say exponential distribution, Landau distribution, some Bright-Wigner formulas, Poisson random distribution, and the uniform random number. So there is a generator which is sitting inside the root. Okay. So you can see I have drawn for you Gaussian, which yesterday we did or today we did, and the Landau. So what is the difference between lambda and Gaussian? You can see the always Gaussian start and there is a peak and we have a uniform distribution left and right. The lambda is some exponential kind of decrease, and here this line. Okay, you can also generate uniform and other functions as well. Okay, so this we have taken from the root manual. Root manual is you can visit on your first or two slides in the same slide. Now I am on the page number 43. Okay, where we have exercise number 3 of two-dimensional histogram. So two-dimensional histogram meaning it is a very beautiful thing which I wanted to highlight you is what this two-dimensional histogram will give you. Two-dimensional meaning you have something on y-axis, you are also filling something on x-axis, and there is a correlation between those two variables you want to find. That is why you are plotting two-dimensional. So if I have something, some two variable measure, two variable, let's say I and V. I want to find the correlation when I change voltage. What is I can see on the effect on I, or if I am doing some, let's say, density distribution, I have a volume charge density and some surface area. So if I'm or number of let's say charge particles which are producing those density distribution. So you can make some correlation plots which will give you the new physics. Okay, so here I mentioned that we can use these two-dimensional distributions for to study the density distribution, to find the unknown interactions. If you are a master student or PhD student working in the nuclear or particle physics or reactions, you can participate in that. To participate in the image reconstruction, so if you have seen our scanning of our body in the CT scan or any X-ray therapy, we have also these kind of plots we have seen. So that kind of study you can also use using 2D, using two-dimensional histogram. So can you see now I'm on the coding part. There is a canvas for you which has a dimension 900 on X and 700. This is the name, this is the title of this canvas. Then we are filling the two-dimensional histogram. So two-dimensional histogram, here I have plotted, here I have scripted TH2F, where what is T? T is the coming from the default, the framework from the root class. Capital H is histogram, capital 2 is the two-dimensional, and capital F is the float type. I would recommend you just hands-on, do hands-on the float type, but always recommended is the capital D, which is a double and which has a very good precision in terms of results. Okay, and on the right hand side here says that you are creating new histogram. You have H1, you have the title, you have put it random number, the binning on x-axis, binning in the minimum scales you are dividing on x-axis, minimum range on x-axis, maximum range on x-axis, binning of y, we here y, what is the binning, what you have kept as a binning on y, minimum y-axis, maximum y-axis. And here what I have said, you can also set the title of those. You can see y-axis, maybe I should minimize. Can you see here frequency and data is coming from this coding that you have put it set title on the x-axis is data and on y-axis is frequency. You can set the title either from the draw panel which I asked to you yesterday and today also, or you can set permanently in your script. Okay, here what is the script doing? We have defined two variables which you can see px and py. These are the variables which we want to fill in that histogram. There is a loop for you, for loop. What for loop says? I equals to 0. It start from 0 and will run till less than 25,000 events, I plus plus. Then there is a class G random. This runner function always give you, this is the class already has in the root default. What this says, yesterday we did a one-dimensional histogram and today itself in one-dimensional histogram the random number for 1D, and here for one variable. If you want to find for the two variable, there is also a a class runner which says that if you want to find px and py randomly, you can use this. And thus, and then fill, let's px is and the py is 2 times of py. H1 fill 2 variable on x-axis, first plate meaning x-axis and the second place meaning on y-axis. So then you set your attributes. What is says colch is the palette histogram, the colorful histogram. What color says here? Color says the density. So where the interaction is more, where the interaction is less, where is the new phenomena you can see. So you see 0 is the less, 0, 100, 200, 300, and this green. So 600 is higher. So here mainly we can see, okay, some correlation is there between data and the frequency. Okay. If you understood this, may I now tell you, should we do this sum histogramming? So what I have to do? I have to go into the exercise cd space dot dot, means I am now out from the exercise number 2. I have to go to the exercise number 3. This is my, can you see this is written exercise number 3? So the same, why I sent all the folders, you should know. I have to prepare my notes in terms of slides. I have to prepare some scripts. The scripts should be well commented with the red line by double slash. And I have to make everything in one folder, not on the desktop or not on the download folder. Okay. So now I'm on the exercise number 3. Can you see Histo 2D? So I have already explained this code I have kept here also, but I'm also sending you the scripts so that you just, when you make your own scripts, what I am doing, Histo 2D and then ampersand. Ampersand is just, I can see this. So here you can again see, I have make comments of all the lines which I am using. Okay. So just compile root minus L, then dot X, then histo dot 2D. Okay. Can you see the here? So I will show you what I mean colch. Okay. Here, can you do a right click, go to the draw panel? I did in center, there is an arrow. Then I click on the draw panel. Can you do along with me? Draw panel, I saw this. Can you see here, box? Here is a palette and colch. I will click on the box and remove the palette. Can you see this? I'll make it as a black color. Can you see this? So this is the box representation of the 2-dimensional. There are n number of scattered plot. Can you see this? And remove the box. This is the scatter plot. Okay. So this where I have gone, please make your notes again. Right click on the plot. Go to the draw panel. There is a very nice options for you. Here, box plot. Unclick it. Then box plot, scatter plot, colch plot. When you click colch plot, then you have to select palette. So if you are putting colch plot, there is no this density bar for you, the color bar for you. When you click on the palette, you can move it also. Okay, I am moving it. Can you see this? Very nice. And then you can see this. If I am not clicking on this just wait. If I'm not clicking on this palette, I will only see this. Then you have to select palette and colch. Okay. So now I'm closing it. Can you also confirm if you are able to compile the exercise number 4 and exercise number 2 and exercise number 3? Exercise number 4 and exercise number 2 and 3. 2 and 3. May I ask to you? You can put a yes, very nice. Okay, please do it parallelly. Very nice. Okay. We can zoom in the screen from our end. Yeah, you can zoom. Why not? Please, ma'am, a little bit maximize the slide. Oh, sorry. I have not seen. Chanchal, please point me if there is a message in the chat box. Chanchal, are you there? Please check the messages because I have shared complete slides,
Okay, ma'am. Okay.
or I can share the only the slides if you are not there, right? Because the student, if a student is asking us to change, let me check if I can. Only slides I can share, not the only I can share the screen. Is Ubuntu has some Chroma issues, so you just say please if there is a question, you can please ma'am little bit maximize the slide. We can zoom. Yes, you can zoom in the screen from our end, your end. Oh, you are answering her, Fatima. Can you see the maximum slide now? Fatima, can you see the maximum slide now? Okay, sorry,
Yes,
right?
yes, ma'am.
Actually, I
Yes,
don't have
yes.
that habit to see when I teach. Okay, so please, are you able? I think you are able to do this 2D histogram. Please, just understand we have to work in a systematic way, and we have to also understand why I'm plotting this. Okay, so then I am on the exercise number 4. And this exercise number 4, actually, there is maybe some resolution problem in this slide. Maybe I can maximize it. What this exercise number 4 says, this is a three-dimensional histogram. So let me explain you. So I am changing only histo 3D, the same name of my script. Okay. Again, the canvas, which has a 900 in x-axis, 700 in y-axis. I have TH3F. Now, I would recommend you try with the TH3D. Also, of course, the representation will not affect, but the results should give the precision value. So if you analyze this box, which is a 2D or 3D, that the result should be affected if you put the 3F or 2 or 3D. So D means double precision, F means floating precision. Okay. So new 3 TH3F meaning you are creating new three-dimensional histogram which has the name of H1. Title is random number. Again, now you have a three variable X, Y, and Z. Okay. So you have to give what? Bin, minimum X, maximum X, bin of y, minimum y, maximum y, bin of z, minimum z, and maximum z. So first number is always stands for the bin number, and the second two number is the range of that axis. If I'm on x-axis, the range is minimum 0 and 20x. So maybe I can show you here. So you have three-dimensional, right, cube. And here you can see 0 to 20, 0 to 20. I have kept it everything similar, but in your measurement, you have a different variable. So you can change it and you should change it, right, actually. Okay, so now what I am filling here is just I am just setting you this set command of the attributes. I can do upside also, out of the loop also, and inside also. It is up to you, but the coding says always define the canvas and histograms are always on the top. This is a bad scripting I have kept for you because I need to explain you. If I always make ready-made stuff for you, you will never realize which is wrong, which is right. Okay, so this is the bad scripting from my side, I must say. What I should do, I should always define on the up top. All files or histograms and canvas should be on the top. Then I should define my variable which I want to fill. I'll come to that coding, and then loop, and then at the end I should change, I should modify the attributes. Here I have done, what I have done is I have modified the attributes before I'm drawing. This is not good. We have to always first fill or draw, first fill and then draw. Okay, so this is wrongly written. Please remove this H1 draw. When you are compiling, remove this. I must say you should draw here always after the fill. Change, please remember, make your notes that you have to first define the canvas, define the histogram, fill that histogram, draw that histogram, and then change the attributes. This should be the order of scripting. order of doing the work in the root or order of doing the programming in the root. Okay, so 3D histogram can also be done. Okay, so can you compile your own the 3D histogram now and check that this is the bad scripting or the good scripting, or you change your own? Can you confirm if you are able to compile the third exercise for me? Take your time, and can you please let me check if I can just okay. Your entire screen available. Okay, no, then entire screen, I think. Okay, meanwhile, please you compile. Very good. Give some time. Yeah, yeah, sure, for sure. Take your time. Okay, I'm here. Please compile the exercise number 4. Exercise number 4. Okay. And now I'll close all the Emacs which is already opened here, and Emacs histo. You can use any editor. For the window user, please use Notepad, and for Ubuntu user, please use gedit or Emacs. And then ampersand says that, or if you don't know how to work in the Linux command, please click on the this part and directly open the exercise number 4 here. Okay, so this is the G editor. Default I have set the Emacs, I hope. Okay, so can you see there? So this says, okay, let me explain you here what I'm filling here. Can anyone tell me what this scripting says? I am filling the random number on x-axis. It says I am filling the random number of x-axis inside the for loop, which run from 0 to 200. It means the last number would be 199, and it is filling the random number which is divisible by 10 plus 1. It is, you can fill any Landau, any Gaussian number, because we don't have a data right now. What I want to highlight you or emphasize you or want to explain you, if you have your own data, experimental theory or calculation, you fill that data here. You have ready your script. Change your title if you are making some experiment or current and voltage or some other experiments in your field of interest. Okay, this ISO means I have already given you this options that 2D histograms can be plotted with these different options, which I have right away shown you the called the box, right? At the similar way, three-dimensional histogram. This can you see on slide number 20? Okay, so here and different options are for you. Lego style, right? Same style, poly style, color coordinate style. Okay, so now I'll go back to the exercise number 4 and compile for you. You meanwhile, please, you also compile so that you will learn where I am. I'm in the exercise number 4. Okay, here. Okay, this is exercise number 4, slide number 44. And I have explained you this script. Now I will root minus L dot X and then histo 3D. I should be inside the same loop, please. Remember, when you are compiling the program in scripting, I should be in the same folder. Then only I can compile. Can you see? I can rotate it. Can you feel? Can you see my screen? I can also rotate it. Let me show you. Okay. I can see any angle or anywhere. So let's say where I can use this 3D. 3D always can be used for the device optimization. Maybe you are doing some making your new device, and you just see if I have taken or build that device with different materials or with the different layers. So I can see that all the layers are built in. Okay. I can also change the color and the title name on the spot. Again, same, right click, draw panel. There is option for you. Okay, fill color. I can change yellow. है ना? This is very nice thing we can do and very quick. Okay, so now I am closing this fourth example, and I will like to know from you if you are able to do this. Did that? Yeah. Surbhi says okay. Chitranshi says please put a success word or yes ma'am or something like that. Milap, yes. Milap, you are a window user. Milap, yes. So are you able to handle that C drive path, Milap? Bhavik, yes, very good. Okay, if any user, I must say, if any user has a problem still in, yes, I had copied the script in the macro. Okay, it's fine. So Milap is saying that I am just now running in the same root folder. Okay, are you Milap compiling in the tutorial folder inside the tutorial folder? No, ma'am. So where inside the root folder? Okay, so if any student who is new and you have a friend circle virtually here, so if you are hesitating here to in asking that okay ma'am in window I am not be able to do this, so please take the help from the student as well. Pin me also, write me email, I'll able to help you. Okay, don't worry if you are unable to do at home. We are here to assist you. So can I move to the graph now in the scripting? Can I move to the slide number 45 now? I think yes. Okay. Yes. Okay. Chanchal, can I move? I think yes.
Yes, ma'am.
Okay. So here is the T graph. What T graph says? Yesterday I explained you. T graph is nothing but the plot which has some dependency. Y function. Y is a function and it has a dependency on X. So I need to do that plot, right? And represent my results. So here is the definition. Again, I am pointing out to you T graph. This is, I think we are doing first time. So T graph name. What is the star? Star is a pointer. So now I will, from now today onwards, I have introduced you the pointer, and the pointer always says I should please give me a arrow. Don't give me a dot, right? Yes, for till yesterday I was this compiling this program that f dot draw, h dot draw. So if you are seeing that star means you are using this as a pointer, and this is the new T graph you are creating. Again, the always in a root you are starting your class start from capital T. You cannot change it. The endpoints here is the number of data points you have, x-axis and y-axis. Okay, so and then draw that SE star. I'll tell you in this later. This is the different option which we can use in drawing the graph. So here you can see you can drawing the this I have introduced, I think, in the introduction part here, right? If I'm correctly remember. So here you can see if you want to draw a y as a function of x. So you are giving that this is the dotted plot AC star. What A meaning here is always x's are drawn around the graph, and the AC star meaning the here smooth curve is drawn. Bar plot meaning you have can take the bar options here. Okay, so there is a now this here is exercise number 5 for you. You have a x, you have a y, which you have a, let's say, assume that these are your own data. Okay, and then you have to draw this graph where you should draw y on y-axis and x on x-axis. Okay, so how you will do the scripting? You will again do some, open your .c file, a new .c file, put a canvas, always create a canvas, C1 here I am just putting the border size. This is the frame which I have. I am putting a border size, a dark border size. Okay, here is the constant n, 10 data points I have. You can count it: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Float, float here. We have the float kind of data on x-axis, and on y-axis we also have the float kind of data. What is this? This is an array which has a number 10. Then there is a definition of graph which I have given you in the previous slide 47, and you can see T graph star gr will give you new T graph where you will put as an input n 10, x will take from these. This is the same you are doing in C or C++, the array definition. Okay, so this x and y will be the input to this T graph, and you just change the attributes of the graph. Gr is the graph, you cannot put h. The gr is the graph, this is the object, star is the pointer. Okay, and then you just put in your representation where you want, and put a title of the color and whatever you want, and then you update your canvas that, oh my canvas, please update and draw the graph. Okay, so here I have kept everything for you. If you fail, then also if you read these slides, it is very beautifully written that open the terminal, open the folder, type root minus L. Where to use now these graphs? As I mentioned, that if you have some data point from the experiment and theory or from your calculation, you want to show some representation, please use the graph. Okay, T graph. Okay, so now can we start the exercise number 5? Now I will give you some work in the exercise number 5. Don't be happy that, oh, everything is there, I'm able to compile. I'll ask you to do something, some changes. Okay, so I have to go into the exercise number 5. Where is the exercise number 5? Okay, so this is 5A. Please go to the exercise number 5A. This is not 5. There is a folder 5A for you. Okay. First, always try to open that script. Don't always just, okay, if you are able to see in your slides, please see how we have done this for you. Okay. Okay, so now I am compiling root minus L graph1.c. So here I have just used a different command for you. Can you do you realize what I did? Root minus L, and then directly I can write graph1.c. Please make your notes. You can also compile not only .x, but you should know root minus L, then space your script. You can also compile like that. This is not a good habit, but still you can use that. Okay, otherwise you will forget, oh, how we can compile. The .x is the good habit, but you can still compile root minus L, then your script name. It will process and it will show you something where, so how I will search. This is the graph. Okay, this is the one-dimensional graph. Okay, so can you now put a title on your graph, on the using this set title on the display? Please, every student should give the title to the x-axis and title to the y-axis. Please do it. Okay, I'll ask few students and they will show me on the screen. Not sharing the screen, I'll tell you how you have to do. Okay, please do it. Exercise number 5A. I'm using x file name.c. It will take macro if it is in the it will take the macro if it is in the macro folder. Yes, this should be you should compile milab in your same folder where your script is there. You cannot compile, right? You should compile in the same folder where the script is. So can you change the title of the graph and one of you show me from your screen? Can you please do it? Take your time, but you should know how to change it. This is the graph. I want to give the name to the title. Right click. There is an option for you. Can you see this on my screen? I want to give the title to the, let's say, y-axis. Set name, set title, which I told you yesterday. Very good. Somebody is there to give me the answer. Very good. Done. Milab, done. Okay, how I should say that you are done? Can you, Chitranji also done. Very nice. Okay. Okay. One of you. Okay. So it is fine. I can understand you are able to do. Yes, done. Very nice. So this way you can learn. Okay. Now I am giving you the second task in the same. Can you change this arrow, not dot? I don't like dots. Can you increase the size of the dot or the come up with the different design? Can you change it in the triangle or any other design? Can you confirm if you are able to do this in the draw panel? Okay. Where? I don't find. Can you point me where I can change the triangle from the circle? Very good. Please participate. You will enjoy this session. Done? Milab, done. Very nice. Oh, very nice. So somebody is showing me. Oof. Oh. Sorry. Very good. Very nice. Who is this? Bhavik. Bhavik, thank you so much for your encouraging screen, I must say. Thank you. So Bhavik is just opening his video and showing us his laptop, and I can see he has changed. So anyone? Done. Shreyansh, done. Very good. Very nice. So I'm happy. So just I'm asking though for those who are unable to do that, I can show you draw panel. Click on the draw panel, and then there is an option for you. Can you see this? There is an option for you, the triangle. You can increase the size of the triangle. Can you see this? There is an option. So I'm making big and big triangle. I have a four size of those triangles. So can you see? Okay. So because if we are putting these plots in the slides and showing in some of the conference or showing in general where the plots is very small on the, let's say, 2-column paper in the proceedings, so we have to increase those size, and we should know how to do that. Okay. Okay, very good. Now I am closing this exercise number 5. Very good. Okay, so what we are trying to understand first, the script, coding, the classes, how to compile, how to change the attributes, and where to use. These 4 things, please remember in any of the programming. Now I am moving to the exercise number 5B. Okay, here you can see that I want to draw the error bar on my data point, no? Right? Because if we have a data coming from any calculation or coming from any experiment, they should have some errors. So the statistics says either error you have to calculate by some fitting parameter x square, some x variable which you have measured, and some true variable which you have which you know from your calculation or from your theory. So x minus x naught square under root of that will be your error, which statistics says. So what the T graph error says that I will automatically will do for you. You don't need to do your own. So this is the beauty and this is the advantage we can take from the T graph. Okay. So this is, again, I will explain the code. This is the canvas. I will not give again and again. This is the name, this is title, X and Y. Okay. So here again, these are the arrays. So here, please remember, I have defined 4 arrays. The data points are again 10. These are, I think, same in the earlier. And this is EX and EY. This is the error. If you know the error on each data point, which you have already done in terms of calculation. You want to show that in the graphically. Somebody is asking you in your thesis defense that, okay, how much error is on your data point? So what you will say? You will open your copies and say, oh, 2%. No, you must show your error bar in your representation. So there is an option for you. So what is that arrow meaning? The plus and minus on y and the plus and minus on x. So here meaning plus, here meaning minus, dot meaning your exact value data point. So can you see this, these four array, x and y is your variables, and ex and ey is the error on the along the x-axis, ey is error along the plus minus y-axis. The this is the circle, plus up and minus is on down on the y-axis. Then t-graph error is the class in the root where you are giving as an input number of data points, x and y variable, and the errors. And then again you are changing some attributes and plotting in some representation, and you're setting the title of the t-graph. So can we go back to the .q, clear my Ubuntu that screen of the terminal, cd ... I'm going out from the example 5a. I should go into the example 5b. Okay, 5b, and then I should open the script graph 2. Okay, please do it with me so that we can understand better together. Okay, and then compile root minus L first, then .x, and then graph 2. Okay, very nice. So this is the T graph. Can you please change the some number in your script? So let's say error on your script, make a big error on your data point. So your error is 0.8. Can you make it a big, the first EY I am saying. So it is on the first data point number. Can you make it as a 5 or 3 or 2? Do it 2. I am just doing it 2 and compile and see the difference. Can you see the difference now in my screen? I have made the y-axis error 2 in spite of the point something. So you can see this error bar is increasing. Okay, so you can change your attributes. You can see how the error bar is coming, or the symmetric or not. Okay, can anyone tell what this distribution is about? Like the name of the distribution, how it looks like? Is it Gaussian? Can anyone say about the name or the distribution it seems it looks like? If you understand what is the distribution. So what is the shape of the distribution? Is the Gaussian? Is exponential? Can anyone tell me if you have any idea? Okay, can anyone tell me what this distribution, name of the distribution? Is it Gaussian? Is it exponential? Poisson? Asking me or telling me? Gaussian? Cube? Gaussian? Very nice. It is very nice. So, so that is why I said that you have, okay, so this Gaussian is like that. If this tail goes there, I must say it would go to be a Gaussian. Okay. Okay, so if I remove this part, let's say, can I, okay, so let me come, which distribution is, can you zoom it and see this distribution like that? Can you do in your screen? I can zoom it. Here, just use your mouse and unzoom. There is an option of unzoom. So I am zooming it, like if I want to see this part only. And if I want to see back my screen, right click on the x-axis because I have zoomed x-axis, and there is option unzoom. Can you do this? If yes, please say yes. Are you able to zoom it? Very good. Can you zoom the x-axis? Yes, and I want to see back my screen. So unzoom. There is a which whatever screen you are zooming or unzoom, please make it as a unzoom so that you can see the this script. Are you able to do that? Zooming and unzoom part? Please do it. Okay. Take your time. What I'm doing is can you see this hand? Once you are seeing this hand, can you see this arrow? Now hand. When you are reaching towards the axis labels, you are seeing the hand. When you are at hand, you see the hand, you just zoom it with your hand. Okay, and then again on the x-axis, do the right click and unzoom it. Okay, click on the unzoom. Okay, how many of you are able to do zoom and unzoom? Can you say something? Okay, I am able to do. Done. Okay. Okay. Only few people are able to do this. Milap, Bhavik, Meher, Saroj, Pragya also, Surbhi, very nice. Ankita, very good. Done zoom and unzoom, very nice. Okay. So I'll come back to my question, giving the answer of that question. Which distribution is this? Because we have another exercise, right? Don't worry for that. Now I'll move to the if some student is facing the problem to change the unzoom and unzoom, please let us know so that I can should move to the next slide with the fresh. Okay. So here is again the exercise number 6, which says that draw the function which yesterday we drawn with the terminal, now this time using a script. Very good. And this, just wait. I need to confirm something. Okay, very good. So you have to draw this function using a script. So this function, what this function says, this time again the canvas, again we have two this arrays. Arrays has some 20 data points. Now I'll not do 20 data points by writing in hand, but I'll make use some loop which start from I0 to I19. Okay, till 19 you have a 20 number. Okay, and then what it says, xi will take 1 to 20, 0 to 19, and yi will calculate 10 times of sine of x, where x again as a will take as an input from I. Right, yesterday we just plotted a sine of x default. Right, so here we will change our points again and dependency on of y on x. Yesterday we did in the using the terminal. Now we will do some with the script. Here I am just changing the attributes. Okay, and some border size, giving the border size of the canvas, and the canvas is modifying and updating. Okay, if anyone has some question on this scripting on the T1, please ask. Otherwise, I will move to compile these T1 graph. Okay, now I am inside the folder of exercise number 6. Okay, please open that at least script. Don't compile without opening this. Okay, this should be a function, but I have kept it as a graph. Okay, so can you see this? I can see this, and this is a very beautiful scripting. Okay, I must say. Okay, this I have explained. So you just say this time I have also just set it the title name and on y and on x axis. Okay, so I'm just compiling that root graph 3.c. Can you see this? Okay. Now I am just giving you this is a sinusoidal plot. I am giving you on the chat message that in the same program exercise number 6 you have to draw with this same script, you have to draw a sine of square x, which I have given it to you yesterday. This function b cos square x, cos 2x nahi hai, please make sure. Okay, this is sine 2x. Plot it cosine 2x, then sine, make it now this time sine square x, C point, then cos x. Make it those plots with the same script exercise number 6, one by one. I am giving you this task here. In the same exercise number 6, please draw these three one by one. Okay, using the script. And now I would ask you to draw. First, draw one plot. If you are able to do everything, then you divide your C. Your C meaning canvas. Okay, divide canvas and plot in, divide the canvas in three parts and show these three distribution. I'm writing on the chat message, please check it and show these distribution in one canvas. We will use exercise number, the same script, exercise number 6. We are using exercise number 6 because one function is already there. Okay, just please take your time. First, okay, you have to divide, take the help from your this slides, how we should divide in the scripting. Please do scripting. Okay, and let me know once you are done. Okay, I'm doing. So we have C1 here. Okay, this is my graph. Yeah, I think yes. So we have C here, C1 with the name of C1. Okay, I think yes, we have this C1. You please do it your own. I'll not do for you. 1, 3, then C1, do it together. Okay, C1, CD1. I'll do only for one, this the same function 10 sine x. You have to draw three functions. One is sine 2x, sine square x, and cos x. Okay, so I'll do C1, CD1, and I will plot this. Okay, are you able to do this? So you have to define GR1, GR2, I must say. Okay, GR1, GR2. Please use F1. This is the bad GR I mostly use for the graphs. Okay, so do it like that. Function always F. I am inside the exercise number 6. Okay, let me check if I can do this, but you have to do your own. Okay, so it is saying that function divide is not defined. Maybe I am doing some wrong. C1 arrow divide. If I can capital divide only. Okay, so I am done. What this says that 1 into 3, 1 column, and this will produce 3 row. Okay, I am done with my first thing. 10 sine x is already produced in 1. I have divided. You just see, it will help you. I have used the C1 divide 1, 3. 1 column, 3 row. First function is drawn. This is just default function I have drawn. Please, what you do, you have to, yes, show these distribution and okay. So this you have to draw this sine 2x, sine square x, and cos x using the same script which is in example number 6. Okay, please do it. So that, okay, ma'am, sorry I joined late because of an, yeah, you informed me, don't worry. You, okay. Notepad script, yes, you will use the Notepad script, and many students have success in compiling all those scripts which I am sending it to you in the Windows machine also. If because you are facing some issues, Either you point me to via email, or you can do Milap is also there. Bhavik is also, I think, no, Bhavik is, I think, Ubuntu user. I'm not sure, but there are, if you find, let's say, some C directory error, yes, Milap, I can help. Yes, yes, very nice. I'm also facing problem with the same. Shilpa, you can just discuss with Milap, because you have to just copy that script which I am compiling, or copy all those script in the same folder where you have root. And I must say root is installed in the C drive. Shilpa and Vikas, if you are a very new user, please either either if you understood what I said, or discuss with the Milab, because window users most of the time face these issues. Okay. Yes. Okay, so I must say you just copy that, let's say my script, let's say what example number 6, in the same folder in the C drive where you have a root folder. If you don't find root folder, please search in the C drive. It mostly installed in the C drive for the window user. Okay, should I close this? Any problem with the Ubuntu user, or with the Mac user or Linux user? Yes. So this is Melap. Yes, Melap is saying that copy whatever script you create in this macro C drive in this folder. For timing, you just run like that. You can also use in my Windows. There is no problem in like that. Maybe some settings is required. Please follow the, and don't forget which which functions you have to draw. You have to draw this 3 function. Okay, because this, yes, these 3 functions. So Milap is helping you, Vikas. Yes, you can try. Okay, and if you still face the problem, please let me know. Okay, please do this exercise using the exercise number 6, or you can, please don't do scripting all together. Write all 3 functions. This a very good habit. Maybe I can suggest you, first write one function and do the plotting, then write second function and do the plotting, and the third function and do the plotting. Meaning at every step, if you are adding something in your script, please remember to compile your program so that you can face whatever the error you can resolve at that time. Otherwise, if you're writing all the code lines of your all 3 function, I must say you will be in a fuss. You just, if you're writing one function, compile your program and see what the error you are facing. Then write the second line and see, compile your program and see what the error you are facing. This is a very good habit of any programmer which is starting the program. Even I must say I'm also doing the same habit. Okay, fine. Okay, take your time. If anyone has some success of adding 2 function at least, let's say sine 2x, whatever I have given, can you show me? Using exercise number 6, in the same loop, you define sine 2x, and you just show me if you are able to plot it or not.
Ma'am, this is the graph of sine x square.
You
It
are
was
showing
generated.
me. Very
Yes,
good. Yeah. So this
x
is,
square.
mm-hmm,
This is x square.
very
And
good.
wait a minute. That one. Second one is I have to run.
Mm-hmm.
Give me a moment.
Yeah. You take your time. Very nice.
This is x sine square x.
Yes, but they are coming in the separate window. This is fine, Mila. But what I'm saying is you plot it in a one canvas by dividing the canvas. Is it clear to you?
Okay, ma'am. I will do it.
Yes, this is Mila. Oh, Bhavik, this is fine. You are able to at least plot it. But my question was, Using the exercise number 6, you plot these three function in one canvas by dividing the canvas. Okay.
Okay, ma'am.
Yes, yes. Very good. Okay, so now I will, you can do it at home also. This is not a, you just write this exercises, or I will also share with you some exercises today, only one or two, because you are doing it with me together. Okay, so please write your question using the example number 6. You can write now also. Using the exercise number 6, write three function. See in the chat box I have given to you. The functions are sine 2x, sine square x, and cos x. I repeat, sine 2x, sine square x, and cos x. Plot these three functions in one canvas by dividing the canvas into three parts. Is that okay? If I am clear to my question? If you are unable to do now, you will be able to do it later on. Okay? Perfect. Chanchal, can you check the emails also? Meanwhile, if some student is having the issues. Okay.
Yes, ma'am.
Now I am moving to the exercise number 7. This is those who are able to do, okay. Otherwise, please do at home. I'll also give you some exercises. Okay. Now I am on the slide number 51. Here you see exercise number 7. This is a very good thing I can show you. Fitting of the one-dimensional histogram. Why the fitting is needed? So please understand with the topic why I need that first. Then you will enjoy when you will do. Okay. So why I need the fitting of the one-dimensional histogram? The fitting will explain your data points, and it will give you the prediction of your data points or coming from the theory or calculation, and it will explain your data point, okay, which you want to explain to the public in terms of conference, in terms of papers, right? And then there is an option for you in the root to fit. If this distribution, this, can you see this page number 51 where you have a blue lines? Blue line is my data point basically, and the red line is the fitted line. So here is a fit panel for you. How it will be opened, I'll tell you. Okay. And then there is an option. The TH1D histogram H1 will fit the value. Maybe I can close this chat and then you can see my full screen. Okay. Some student has, okay. So then there is a possibility to fit Gauss function. Okay. Okay, and then just click on the fit here, fit. So this, the H1 histogram, which is the Gaussian histogram, will fit the Gauss function which is coming in the fit panel. So how I will do that? This is exercise number 7. So can you move to the exercise number CD space dot dot? Just wait, some student is writing on the chat message. Okay. Okay, very good. Shilpa is able to do it. Okay, so the other guy, Vikas, you also please do it. Okay, very nice. I'm very happy that you people are helping to each other, right? And I'm also happy that I'm able to do with you, with both the users, Ubuntu and Windows. Okay, so very nice, good exercise. Now I am moving to the exercise number 7. Okay, so this is, I think, exercise number.
Ma'am, this is just exercise 1.
Okay,
So,
so please
yeah.
move to the exercise number 1. Thank you. Can you see? Yes. So she, why she is
Sorry,
pointing us?
exercise 2. Exercise 2.
Okay, so this is exercise number 2. Okay, thank you, Chantal, for pointing us. And this is histo. I am in the exercise number 2. Please make a correction in the slides that the exercise 7 is compiled in the exercise number 2 folder. So why I am doing that? Okay, I'm not bothering for the scripting, because we are already done with this function. This is the histogram. Sorry, histogram we have already plotted in the previous, right? And what I'm doing is here, I am just want to show you where this root fit panel will come. Okay, root minus L dot X histo 2D. I am in the exercise number 2, please, and I don't want to fill it, so I will remove this filling with the white plot. Okay, and I want always to make my data point in the black point, dot point here. Can you check show marker? First do it, fitting we will do later on. Draw panel, clicking on the right, draw pen, right click, then draw panel, here show marker, and then dot. Your data point in any journal or conference paper, you see your data points are shown always with the dot points. You can change the size of the dot points. Okay, now you can see bigger dot points I have made for you. Now I want to fit this data. Okay, again, not right click on the histogram. Can you see the fit panel here? Can you see that this is draw panel, then fit, and then fit panel? Please click on the fit panel. Okay, here you can see this fit panel. The default is Gaussian. Okay, then fit it. Can you see that this line is coming red color? So this is fitted. You can also change the range. Here you can see X minus 3 and plus 3. You can change the range also by dragging it. Okay, what I did, I can repeat it if you are unable to catch me. What I did, I have just right click on my data points, which are here dot circle. I wanted to make it as a show marker, any different color, let's say triangle, because the data points in journal or publication is used for dots. Then I am again going back to my data point and clicking. You can see fit panel is after the fit draw panel, and then fit panel. Then I'm clicking on the fit panel, dragging it here. And you can see TH1D, H1, and then Gaussian is the default. You can also change you can also change the parameter, you can change the range and fit it. So you can see this red line is the fitted line. Yes, one more thing. Can you all save this plot in PDF format? Please save this plot, which is in front of your screen, which is exercise number 2. How I can save it? Can you save it is in a PDF format? Okay, let me come on the chat message. Yes, ma'am. Very nice. Very good students. I mean, very active students I have. Okay. Very good. So where I am? PDF. Can you click on the PDF if you are able to see those plots? Okay. So how, if those who don't know, I am doing in front of you, can you see? File, then save as, then there is a PDF automatically coming. You can save it as a GIF also, you can save it as a PNG also, JPG also. Okay, and give your name as you want, and give your folder where you want to save it. Okay, I think. So please save those plots, because you should also know how to save and how to make it for your LaTeX. And please, I would be happy if I can see some plots compiling in your LaTeX document if you are doing parallelly in your next classes. Okay, save it this as a PNG and use in your LaTeX class. I would be happy to see. Okay, this is also your exercise, that you are using the PNG file of this session and saving it in your document, let's say in the LaTeX session. I would be happy to see that. Okay. Okay, fine. Now I am moving to the, if we all are done, now I am moving to the exercise, page number 52 of the slide. This is the stack histogram. Okay, I think how many of you are unable to do that? Stack histogram was a homework from yesterday part. How many of you are not be able to do that? Stack histogram. Okay, so I can explain, but I will not compile this because this is this was our homework. But I can give some highlight some points which I want to do, want to give you. So this is the, can you see this slide clearly? This is HStack class of histogram. Star HS, HS is the object, star is the pointer, and this will add all your histograms which you will define in my further here in your coding. So let's say if you don't have a data, as I said, we are filling in terms of Gaussian. You can also fill in terms of lambda. We have already introduced to you. Fill different colors, K red, K blue, and the K this different colors. So we have, let's say, 3 histogram. Okay, and 3 histogram has all the Gaussian but has different number of events. So let's say you have a data from different experiments and you want to compare it, or from different your calculation and you want to compare it. So you just define a HStack histogram and then just draw it and draw it. And then there is also a very good point how you will distinguish. So there is a label for you which we have added, and H1 name, L lines. You are showing this line and this color is taken automatically from the histogram. If I change the color in the histogram, that label will change. Okay, so this is a new thing I have added for you. Please appreciate that we are introducing you a new thing when you are growing and moving towards the next tutorial. Okay, so please take that advantage. This labeling will be useful for your thesis, that you have a number of data and you want to put it in a stack or a combined form and you are labeling it. The change you automatically, the change, you will change the color of the histogram, it will change. I would appreciate if you do compile this and change the color of your histogram in this script and see if you are able to do. Please compile the stack histogram. Chantal, can you point me which exercise is this? If you have this exercise for the student here.
Yes, ma'am.
Yes,
Is
stack
stack
histogram.
histogram.
Yes. Thank you, Chantal. So Chanchal is my PhD student. She's very good in explaining to you, and she's observing from you that you are doing very good job here, right? So, I'm in the stack histogram folder. There I have opened the same exercise for you. I want to change the color of the histogram and see if and I want to change the title of the histogram. Please change the color of the histogram and add the title of the histogram. The title of the first histogram, I'm just putting you in my chat message that you just gave it this. Stacking can be also, someone is asking, when can the stacking be done directly to the root instead of script? Yeah, we can do that directly, meaning bole to on terminal you want to say, Shreyansh, if I'm correct? Yeah. With this, everything can be done, whatever you are doing in the script. I would appreciate if you do in the script. But yes, Shreyansh, are you able to do the scripting or not? Can you give the answer, Shreyansh? Yes. So this is fine. You can ask me any question if you have a. Okay, Chanchal, please make sure the student is asking question and this at the same time we are replying. Okay. So now I want to change the H1 histogram title is let's say experiment 1. See the chat message, please. H2 histogram experiment 2, H3 histogram experiment 4. This is actually I tried yesterday in terminal but couldn't. No, no, no. We can do. I can do for you. Don't worry. Okay. Stacking. You have to define the. Okay. You are saying stacking is not possible. Maybe you are doing something wrong. You did you define this? So you don't get out from the terminal. Be in the terminal. Use, let's say, this h stack, then h1, then don't change the attribute, just fill the h1 and then h2, and add the h1 and h2, and then you will see. I hope you can do it. There's no problem. If not, I will. Is it possible? I did it terminal only. Yes, Chitranshi is saying she has done. So please don't distract this tutorial. You have to change the title experiment 1, experiment 2, experiment 3, and change the color of the exercise number of stack histogram now. Okay, this h1, h2, h3 should not can be should see like experiment 1, experiment 2, experiment 3. Do it. We will take 5 minutes break here. Meanwhile, you can also have some tea. Okay, 5 minute break meaning 5 minute break. 4:07, 4:10. Okay, 4:15 we can meet. Meanwhile, you compile it. Those who don't want any break, please compile the stack histogram. And Shreyansh, if you are not taking the break, you can do on terminal. So I am taking, let's say, 2 to 3 minutes break. Okay. Yes. Okay, so I'm back. Okay, you can take few seconds more. So I am on the slide number 54. Is that okay? Should we start? Okay, okay. We will not waste time because it is. Okay, so now I am back and we are on slide number 54. Yes, so far what we understood is we understood how these results from theory, calculation, or experiment can be represented in terms of graph, can be represented in terms of histograms, and that those histograms can be fitted using some function through the fit panel. Okay, we can do same thing, how those histograms can be also stacked in one canvas, how the canvas can be divided, we understood like that. Okay, and this is these are very basic and good exercises which you participated so far. Now I'll be moving a tricky task for you, that we should also understand uh, to what will be the container for me to put all these histograms in there. So let's say if you are a Excel user, so the Excel contains some file where you have a different sheets, right? If I'm correct, and then in that sheet you can plot the distribution. If you are a user, which you know that we have an Excel file in Office, and then you have a different sheets inside the Excel file, and then you can plot some bar chart or a line plots all those distribution. Those distributions, the sheets are the container of those distribution, and for the sheets, the files, Excel files, are the container. Here what I want to ask you is those histograms and those graphs and those canvas, what will be the container for them? There should be some container which will be the mother for them to keep everything at one place and zipped them. Okay, so this is what we will introduce you, the root file. The root file will be container of a data, the huge data which we are going to analyze, which we are going to reconstruct, which we are going to simulate. Okay, so we at the end we need some file. Okay, so that is the root file, which saves all the data in different forms, which forms we already introduced to you, are the histograms, are the T3 and tuple we will introduce to you. So we have to somewhere we need some file which create all together all those histograms, right? We cannot pick all those histogram in one folder and say, hey, this is my folder. Folder is separate thing, is the working folder, working directory, but I should have some file where I can pick that file and all the histograms are aligned there. So there is a file for you which we will know how to create. T file star f, star is again a pointer, f is the object, new T file you are going to create. This the name of file, dot root is the extension of that file. Okay, and then recreate, you are creating. Reading, because if you have, let's say if Bhavik has created a file and Bhavik want to, in that file Bhavik has a 6 histogram. Okay, and Bhavik wants to, I am his supervisor, and I want to see that only one histogram out of, let's say, 10 or 100 histogram in that file. So Bhavik will point me, ma'am, you just see that one histogram. If I want to see the variation of my experimental conditions, let's say if I change the temperature and I have a 10 histogram, I will not send a 10 histogram in my Gmail drive or through the Gmail. What I will do, I'll make one file, save all the histograms, 10 histogram in that file, and send it the root file. And my supervisor or my collaborator can see, open that root file in the root environment and see the variation together. That will be a quick and complete task. Okay, so where we can use the root file, storing the root file, as I said, analyzing the root file, by discussing, by sharing the root file on the common platform. So this slides is says that what I mean by the root file, how I create, and how I read as a user. Let's say I am the supervisor of one of you and you want to show me the results, 10 histograms or 100 histogram in a one root file. I need to read also. Okay, then I want to know how I can read it. So we will learn this thing in the next slide, which is the slide number 55. Okay, so this is the slide where I will train you how I will create the root file. Okay, so I can explain you first. This is the T file, star ren1. Ren1 is the object. T file is the class of the file. New file, T file, meaning you are creating the root file with the name, and having always don't forget to put dot root, please, and then recreate. Okay, then there is a histogram, which you already know how to create it, and you are filling this time Landau. Can you see Landau distribution? And now you tell me, what was that distribution which you were saying poison? This was not the Landau. Okay, maybe the tail was not there. That is what you say. It is look like a Landau, right? If we do all the experiment, it was this and this, right? The question I raised in the last plot, in the graph time, the plot was like this and then stopping here. If those data point again taken, then it is could be a Landau. Okay, so the Landau I am filling in the histogram, and here is the new command for you, h1 write, which write the histogram in that file. I am not drawing the histogram. Please remember, I am not drawing the histogram, but what I am doing, I am writing the histogram, and I am closing the file. Ren1 is the pointer object of my file, whose name is ren1.root, having the extension .root. So you have what you have. You understood if anyone has any question on the what I have to remember, I have to create a root file. I have to create a histogram, fill histogram. Don't draw it this time because I have to send it to my supervisor via email. Here you can draw 10 histogram, more than 8 histogram, write it, but don't forget to write it. Write it meaning you are writing those all histograms in that file, and that file don't forget to close it. Otherwise it will not be readable. Okay, like the same you are working in the Excel or any other software. So now I am giving you a hands-on. I am moving, I'm clearing CLEAR. Okay, I'm using the Ubuntu, but you can all use in the window, do this for the window. I'm in the exercise number 8. Okay, and I'm opening this ren1, which will tell me how to. Please open the code. Okay, and here you can see how I have commented it, creating a root file, creating a histogram, filling the histogram, Landau distribution. Landau distribution is automatically a class of those random number distribution which we have introduced. We are writing the h1 into the file, we are closing the file. These two steps don't forget, okay, while doing the programming. Now I will compile ren1. So what you expect? You expect you in the same folder, you will see ren1.root, which will be created. Okay. Then again .q and then ls, or just dig into that folder and see. I can see this. Can you see this ren1.root? I have created. This is automatically created if you compile this. Can you see? This is my script which I have sent it to you, shared you, and this is the file which is created right now. Okay, how can I open this root file? Again, root -l. Okay, T browser R. Click it. There is a root file. Then there is a histogram. Can you see what I did? I repeat what I did. I'll do I'll open that root ren1.root file which I created through this script in the exam exercise number 8, and I'm doing root minus L, then T browser R, and then this will open this GUI graphic user interface for me, and then I'm clicking on the ren1.root file. Please don't click any other example, and there is a histogram for you, H1. Can you see this histogram picture here? And then click on that, you have the same histogram which the for which the entry, you can drag it, see, change the color, again the same thing which you did earlier. I'm changing default, the root is taking blue color. I can change in my script also, I can change it here. Are you able to see this at your end? Please point me if you are not, I can help. Okay, there is a commands, we have also mentioned all these commands here for you on page number 55. Please look into the page number 55. Open
Show it
terminal.
once again.
Yeah, show it once
Someone.
again. Okay. So if you don't understand or there is a problem in the net, please page number 5, follow the page number 5, open the terminal, root terminal. He's saying go to the folder, run that folder root minus L, then T browser R. I can show you, don't worry. Okay, I'm doing it again for you. Just see, I'm just showing you my terminal. Okay, so that there is no problem. I'm inside the exercise number 8, root minus L. Okay, and then T capital B, browser, T capital B, browser, and anything, any word from your keyboard, L. It will open this GUI graphic user interface for you. There is, you can see exam, I am inside, there is other example as well, and there is exercise number 2 ren1.c. Here the file, can you see this file? I am double clicking it, there is a histogram, and I am again double clicking it, there is a histogram. Can you see this? Are you able to do now? Can anyone let me know if you have a success? Just root minus L, then T browser, some word from your key, some letter from the keyboard. Then you have here ren1.root. If you are inside the same folder, then double click on the histogram, you will see the histogram. If you have 10 histogram, you will see 10 histogram. Okay, this is the same file which you have created in the exercise number 8. Okay, is that okay for you? Okay, I think there is a check message done. Okay, okay, very nice. So are you happy? So you understood where you will utilize this root file. You will use it as a container of keeping all those histograms, all those graphs. Okay, there please remember that the H1, okay, I will close. No, I should close it, but I can arrange my Chantal, can you see now what you can see in terms of screen? Are you only see the slides now?
Yes, ma'am.
Okay, not the terminal now. Okay,
No,
that is
no.
fine. That is
Yes,
fine. So please, we have also, if you are lacking in understanding, we have also kept for you, but do it along with me. Okay, that would be nice. Okay, can you add another histogram in the same file? Can you do this now? In the same script, we will add another histogram and we'll see if I can add 2 histogram in creating a file.
Ma'am, someone asked what is T browser exactly?
Okay, T browser is the GUI graphic user. How can you see then the, if you, okay, so root has an advantage. Milap is saying new histogram file, we need to close the file every time or just add. While creating the new histogram root file, we have to go exercise number 8 folder. We can save it anywhere. Yes, you see, this is your, this should be your working folder. Okay, For me, I have made it as exercise number 8. You can say whatever, wherever you want. Okay. While creating the new histogram root file, you want to Chitransh, you want to ask root file you are creating, or you are asking histogram? I don't understand your comment. You can save your root file wherever you want, but it is always good where your .c script is there, only the results of that histogram should be there, so that you understand. Otherwise you will be in that position that you don't understand which root file this is. Chitranji, if I'm clear to your answer question? Yes. Milap is asking, ma'am, each time we write a new histogram to a file, we need to close the file. No, closing of the, so let me come on the, yes. So this Milap is asking that, ma'am, if I create a new histogram and writing it to the file, should I close the file again and again? No, no. The RAN one is the single file. You have to close it only once. You have to write n number of histogram. Like if I say, can you see H2? Right? H2 is my new histogram which I will create. Okay. And I have to define H2 also. Okay. I have to define H2. You will write, but I have that habit of cut paste and doing things. So you just, I'm defining H2. Okay. The same meaning, same number. But this time I am defining Gaussian. Okay. Gaussian. So H1. Chantal, if let me know if it GAUS. I think yes. It's H2. Yes.
Yes,
So
ma'am.
see, I have created two histograms with two different name and two different title. Filling in one H1 Landau, in H2 I am filling Gauss, and then H1 H2 writing, but the file close will be only one time. And now I'll compile .q outside .l, and then I will compile .x ren1. Okay. So then there will be, you can see there is a file. I'll see, and some student are asking what is the T browsers will, what you are doing with the T browser. You have to check, you have to see your results. So T browser will give you a GUI interface, graphic user interface. Will you see the visualize your results, right? Without GUI interface, you cannot see your results. Okay. Can anyone are asking? Yes. Okay, Meher. Thank you. So I am just opening that T browser R again. I want to see if I created two histogram or not. Can you see this two histogram now in my screen in the same file? So one is this, but I can also do one more thing with this example. I can go into file, new canvas, and I can show you those two histogram together here. Can you see this? Can you see this? One is Gaussian, one is Landau. How I did this? I have just click on the H1 first. There is a default histogram for you. Then I went to the file number, file, and then new canvas. Then new canvas will be default created for you, and then click on the H2. So you will see two histogram together. Can you see these two? Are you happy? I think yes. Okay, then save it both two histograms. Okay, if you want to send now to other user or your collaborator, you can send this root file, but the person should have the root installed in her or his laptop. Are you able to do this, or anyone has some question? Okay, so now I am closing this. Hope I am clear to every question you are asking to me. Okay, fine. So now I will jump to the my slides, page number 56. Okay. So are you able to add a second histogram Gaussian in page number 55 in your script, exercise 8? How many students are able to do that? Can anyone point me if you are able to add those two histogram in exercise number 8 example? Okay, if not, then what I will do, I will make some small exercise for you, like you did today, na, at your home. So uh, hopefully you will be able to seeing the same way. I will not now share you the code, but you have to prepare your own code inside the same folder. Okay, I have added. Any question at present on creating the root file? If yes, then please ask. Otherwise, we should move to the page number 56. Now, this is the reading existing histogram from root file. This histogram is the histograms which you have created at your place, and you are sending it me to a root file. Okay, and then I'm reading those histogram. Okay, so just wait. Somebody is knocking at the door. Just wait, huh? Okay, so I am back. So this is what I was asking you is that this histogram in a root file you created, and you sent me this root file, and I am sitting at the other place. I have the root installed in my system. So how I will read that root file? Either you will say, ma'am, using tree browser you can see the histogram, right? But if I want to analyze further, then in the script, how I can read it? Either I can visualize it through the tree browser. But if I want to change something or further analyze that root file, what I will do? I will do this this scripting. This scripting what this says? This says that this time I am not putting a recreate because I am reading, opening the file. Can you see the difference of the previous? Here I have put it recreate. Can you see this page number 55? Recreate. Okay, here I am saying that only read. So there is no recreate command. This is the new histogram I am creating, and I am getting this histogram, which is a th1f, from this get this file f. This is the scripting. This is the style. You can get the histogram from the existing histogram from the file. You can read. Okay. So get meaning you are reading that histogram from f file. The f file is defined here, and there is no option for recreate because you are opening and reading the file, and then draw it. This is the reading and drawing from the script, another script at the by the different user, okay, like me. And you can directly, using the T browser, you can draw it. There's no problem, but like I did for you in the previous exercise. Is that okay? Any question, any doubt on page number 56 or slide number 56? Okay, is that clear? Okay, now I will move to the page number 57 and introduce you a new thing, new container. So what do you mean by container? The file can save the histogram, but if I want to save the variables, let's see, there is an experiment going on, and we are storing the online data of that experiment in the computer, in the computing system, in terms of, let's say, current and voltage, right?
Ma'am, someone asked about the work of pointer.
Okay, work of pointer, very nice. The work, okay. So Pragya is asking, what do you mean by a work of pointer? So the pointer meaning, so let's say pointer meaning, let's say you are using some class, okay? This class, let me point into this. You are using this class directly, Pragya. You are not creating your own class, okay? I think you are a new user. So what we do in C++, we have already a defined class there, which is a T file class. And I am just using that class by making some pointer object and using that pointer object to get everything, the histogram inside that root file, right? So, and I can delete that pointer at the end of the program so that the space will not be consumed. So the maximum use or the most of the use of the pointer is, the mainly use of the pointer is you are using the features of that class just by defining the object using the pointer. It will take the less memory, and we can also delete it when we do it in terms of destructor or constructive programming. Is that, if I'm clear to your question? Okay, Pragya. So if you are new user to the C++, these pointer will help you to utilize all existing root classes. Okay, and leave this delete this destructor when the programming is finished. Otherwise, at the end of the day, when you do these analyze so many root file, your desktop says that you are full of memory, your computer says that you are full of memory. But because you are using the pointers and you are just using the file which is already in that root file, in that root atmosphere, and you will delete also when you will do a good programming. This is just, we are doing a basic programming, and we are just sensitizing, or you get familiarized with those stuff which is you root is giving. But when I will be developer, let's say Pragya, you will be developer and you want to utilize that, then you have to create so many classes of root together. So how will you do that? You will create some pointer at the top, and in the constructor, then you will delete it because you have used it in your some part of your programming. Then you will create a new pointer and then you will delete it. So your memory of the program or the memory of your system will not be consumed. Okay, and you are directly using those classes of the already standard classes of the root. Okay. Okay, so now I will move to the page number 46. Yes, 57, sorry. What is the T tree? So, like we have one bag, okay? And if I'm going to the market and I'm just putting everything, whether it is a vegetable or whether it's the milk or whether it is everything or the sugar in one bag. The bag is a T file for me. So when you will be reaching to your home and ask your mother, please separate all the stuff and put it in your fridger. What you will do? Your mother will be in a fuss, in a problem. So what we will do? We will not keep all the variable, all the histograms in the T file together, whether it is apple or vegetables or anything else, or sugar. What we will do, we will arrange those things variable in terms of those stuff at home in a tree. The tree is like arrangement of all the variables in terms of some good management thing. And it has a, so I cannot save directly the variable in file. I can only save histogram in file. So if you want to save the, not the graphic in the file, but if you want to save the variable in the file, please make it clear. I repeat, if you want to save the graphics meaning histogram, graphic meanings the graphs you have created, graphic meanings the canvas you have created in your previous sessions, previous tutorials. Now I want to do some experiment and I have a device, okay, and I want to save that. I started my experiment now, and after 2 hours, I want to see those data which is saved in the computer, right, or any meter where you want to measure it. So what I'm saving it is a variable, not the graphics, because those variable I have to analyze. Is that clear to you? What is the graphic I mean, and what is the variable? The variable is the output results of from your experiment. Okay, the variable meaning current and voltage which you are going to measure. Okay, so I want to analyze further when I am here offline. The experiment is being done at some point, but it is not compulsory for you or compulsion for you to analyze those experimental data now. You can do it offline. You can give it to the other user. They will analyze if they know the programming. So those variable we should not save it in the terms of desktop or any folder. We save it in some arrangement that is known as a T tree. The T tree will, like if I say, I am on the slide number 58, you can see that the structure of T tree is arranged like we will see the branches and then we will see the leaves, and the leaves will save all the variables, whether it is a integer, whether it is a double, whether it is a character. So what I'm saying is, this is the browser. This is the T browser. I'm showing it to you. I'm on the slide number 59. Okay. So you can see, can you say this? This is the tree. Okay. This is the branch. And this is the leaves. So T browser is giving you the possibility or the very good features where you store all the data variables coming from your experiments or from simulations or from theory. Save it in terms of different leaves. Those leaves can be a variable in terms of floats, in terms of double, in terms of integer, in terms of current, in terms of voltage. Save it in terms of those leaves are the branches of a tree. So you have seen a real tree, like that only I am talking about. Okay, the real tree has tree, then the branches, and then the leaves. So the leaves, I have different things stored from the experiments. And now I can analyze and make my graphics, make my histograms, make my this canvas. In the canvas, I can show the graph, I can show the fitting of histogram, etc. So am I clear to the T tree stuff? What is the T tree and what is the T file? T file is the container, like a bag you have. But the T tree has the ability to save your experimental data or theoretical data in terms of variable. So in T file, you cannot save the variables, but you can save the graphics. Is that okay if I'm clear? So here I'm on slide number 60 now, and I'm showing you that this is, can you please, should I zoom it and show you clearly, more clearly? Can you see this now? I think yes. So this is a file. So 3 dot is a file, which is a zipped file. It is a similar, you see in the zip version in the window user, you see this is the zipped file having the extension .root which you created or which is coming from the experiments. Okay. Then this is your tree. The tree is here, and this is the leaves. I have not shown you the branches, but I have shown you here in the previous thing. So this is the tree, this is the branch, and this is the leaf. Okay, so this is coming from the which you will generate today. Okay, this which you will generate. Maybe we can start from tomorrow onwards with the fresh mind. So but you should understand the significance or the meaning what we are doing. So let me complete 61 slide and we will create later on. Okay, how to create the root tree in a file. Okay, so file, you know, we have created just now in our previous tutorial. The T tree will save all the data in terms of branches, as I said. What is the commands which we should use? T tree start T, new tree you are creating with the name and with the title. You are filling the data in terms of branches. So what it says, T is the pointer object, branch is the class of the T tree which you are using for creating the branches in the tree. Branch one is the, so it is not like you can save the variable in terms of momentum, in terms of current. This is the name of the variable which you want to save. This is the address of the variable which you want to save, and that the variable is float. This is the type of the variable which, so here is, it is written f is the data type. So if I am measuring, let's say current, so current name, current address it will ask, and the current type, so float. Let's say I am storing let's say COVID-19 patients, how many COVID-19 patients are increasing for, let's say, in August month. Okay, so what I will do, it should be an integer, so I will do number COVID-19 patient, the address meaning it will locate the position from where, let's say, Jaipur city, and then it is the float, not the float this time, this should be I, integer. Then I will write t is the my tree, and I will close the file. So it means the file is the bigger, the bag I have, and I have, when I'm going to the market, I'm keeping everything, the small bags, right, and I'm keeping everything arrangement. So the tree will give you that facility. You can save the variable coming from your experiment in tree, but you cannot store all those variable in file. Through the tree you can store these variable in a file. So file is a big container for you, tree is a container for saving or storing the variable with a small size, quiz size. Okay, and at the end you have to create the tree. Remember those two things, histogram will be created, tree will be created, but the file will be closed. If you don't close the file, it will give you the error, you will not be able to read. So I stop this session now, and I'll create the tree tomorrow, right? So I'll summarize this talk now. What we learned today is, we learned scripting, how to compile them, how to divide the canvas, how to plot the histogram, function, fitting the histogram, how to create the graphs, where all these things will be used, how to create the file, what is the file, where to use it, what is tree, how to create it. We have not done, but we understood the concept of the tree. So I finished this lecture here. For few of students, you are asking me where to submit, ma'am, the assignment. Please submit in the classroom only. Okay. Now I open this session for the question. You can unmute the your microphone and ask. You are welcome. So already we have discussed many things, but it is always good to ask you if you are facing some issues. If you are not be able to understand, please point us, email us, and we will help you. Okay. And please, I would be happy if you use few of those pictures in the PNG form or in the PDF form, and try to understand how to save in the LaTeX, in your LaTeX PDF. I would be happy if you show me tomorrow my results during the compiled during my session in your LaTeX file. Whether you are making it a report, or yesterday you did something with the Anis sir, the presentation. Please try to save your plot which you have created in your LaTeX file. This would be very good exercise for you people. Okay. Okay. Okay, Vikas, and all other students who are the user of Windows, please don't hesitate. Even the user of Ubuntu, don't hesitate. We are here for you to help. Okay. Now I hand over to this session to, I think Ritu ma'am is already there. Ritu ma'am, are you here? Can you hear us? Okay. So if anyone has any question, okay. Okay, ma'am. So I think now Ritu ma'am will take over this session. Okay. So please ask, like, this is a very good question, that pointer, about the pointer. right? So what is the requirement to understand this course better? Maybe Ritu ma'am will connect, I can explain you. This was clear that okay, I tried my best that I should explain you, but that okay, how this programming is working. But if you are a very new user and you want to proceed in that, please, there are a number of tutorials available in Windows, in the C++ programming. So just visit those websites and learn a little bit about the C++. You will gain more and more in terms of graphics and programming. Okay. So now I'm done with my part. There is a session tomorrow will start, I think, from 2 o'clock. Okay, I'll take from 2 o'clock. I'll send it today itself, the link. From 2 o'clock to let's say 4:30, I'll take 4:30 to 5:30. Ma'am will take, Ritu ma'am will take, and at the end we will have a 15-minute session for the validatory. Okay. So please, I would ask you to send us your passport size, a good quality of passport size of photo, so that we can make it and we can present something to you, and the certificate will be distributed tomorrow. Okay. So now, Ritu ma'am, can you hear us? I think she, yes. Okay. So I welcome you for this session. Now you can take over. Okay. 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 So your recording is done. I'm not stopping it. Should I stop it? No. Oh, okay. Yeah. 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 Okay. Okay. Okay.
Kavita ma'am, can you hear me? Hello everyone. Good afternoon. A very good afternoon to all of you. Can you see my screen? I have my latest window open. Hello. Am I audible? Kavita ma'am, please stop sharing your screen. Can you see my screen? Okay, okay. So any doubts so far? Whatever we have already covered. Did you get all the commands? I shared you the text file also. I hope there are no extra sounds now. Okay, now let us come to this. Hello, is it fine? Okay, so let us start. So far we have discussed how to put your title, how to uh, structure your document, how to write the mathematical equations. Now, few important things that everybody want to ask is how to include the figures, how to make the tables, right? So let us come on this part of including the figure. So the command is slash include graphics. But you are saying that as I am typing, it is not helping me. It means it needs some package. So let us use that package for the graphics. So the spelling is graphics. Okay. So take care of this. This is graphics. Now let us go again to this include graphics. Earlier it was red highlighted, but now it is normal. So again, let us try using this include graphics. Okay. So here it is showing you four options. So include is for file, include graphics that we want. So let us use this. So there is this key values and then the name of the image file. This image file, this may be JPG or PNG. Okay. So let me put a picture uh, in this folder where I am working. I am working in the folder that is workshop. So let me put a picture in the folder. Okay, let me take some pic from here. Let us say this is LR circuit. Okay, and let me put it in the folder, this workshop. So this is a JPG file, and please take care of the letters where they are in uppercase or the lower case. So this is LR circuit, and this is in the same folder. So LR circuit. Okay, but now here this is optional part where I can give the size, the scale. If it is originally one size, then I can give it 0.5. Let us compile it. So what is the issue here? This means this file is, let us check whether it is JPG file. It is GIF file. So we need some JPG file, right? because it will recognize only JPG and PNG files. Okay. So let us take this file. So, okay, let us compile this and build and view. So we see that this image file has been included in our text file, right? This is our text file that we were working on. But now if we want to reduce the size, this is already 50% of the original size, but I further want to reduce it. Let us make it 0.2 so that this is 20% of the original size. Now you can see this is 20% of the original size. But also you can give here predefined width, let us say 3 centimeter. Then this is width 3 centimeter, right? If you specify height also, then comma height equal to, let us say 5 centimeter. Okay. So in that case, aspect ratio has changed. And if you are given only one side parameter, aspect ratio will be maintained. Okay. Let us make it 5 and let us make it 3. So again, the aspect ratio has changed. So there are multiple ways of giving this part command, that whether you can scale it or you can define the width and height. But mostly we want the figures in the center. Okay. Okay, so begin center and end center. Let us remove this content part and put this include graphics in the center. So now when you run it, so you get this at the center. But you want again figure numbering also, then we need one more command, that is begin figure, end figure, right? And put this whole thing here. And let us see what happens. Okay, but now you are seeing that your text is before the figure and your figure is before that. So the placement is defined here. Begin figure, and where you want to place it, at the top, at the bottom, or here only where you have placed it. Okay. So you get it, how to include the figure, include the graphics in your LaTeX file. But still there are few more things. That is how to caption it. So for captioning, here slash caption. So the caption command This is caption, and here it is sun. So you may put your caption here. Mostly the caption for the figure is below the figure, but if you want it above the figure, you can move this caption from here to here. So that doesn't make any change, means like your caption will be moved up above the figure, but it looks better here. And also you are seeing that you are getting a figure number. So getting a figure number also. And again, if you want to change the figure number, just like you define number within equation section, similarly you can define number within figure section in the preamble. Okay. Now, suppose you have inserted a figure and you want to include it later on. So you want to add a label. So always add a label key, any arbitrary label you can give, and then you can write in the figure. Now which figure? So slash ref and figure. Okay. So the same number will appear here. Right. So numbering is since based on the section part. So you may want to change it. You may change it from the preamble part. So number within equation is section. So suppose we move this subsection, let us say. Then it is taking the numbering 1.1. And it can be customized. There are things that you can customize this figure numbering also. So this is the complete command where you can begin the figure, then begin center for centering it, include the graphics, put your caption and label it. Right? For a figure, you use all these commands. Okay, now let us come to next part, that is the tables. Okay, for tables, again, slash begin tabular. Okay, and as you can see, it is showing you the help where it is saying that begin tabular, position, then the number of columns, okay, and end tabular. Okay, so I'm using this command. Position, again the similar commands, H for here, T for top, B for bottom. Okay, so position part I am not considering here. Columns. Columns is like, suppose I am having 4 columns. So I am writing C, 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 C. Now here C doesn't stand for column. I will explain what C stands for. Okay. Now here comes the first row. First row, let us say serial number. Then you place a tabbing character, and let us say it is name or ID first, ID, then a tabbing character, then name, then a tabbing character, then the rank. Okay, so this is your first row with 4 columns. So there are 3 tabbing characters. Now give a line break. After line break, now let us say it is serial number 1. Give some ID, then tabbing character, and some name, and let us put some, then tabbing character, and then put some rank. Okay. Then serial number 2, tabbing character, let us say rank is 30. Now let us compile it and see what happens. So you are seeing here the table. Again, if you want to center it, slash begin center, okay, and place your table between this center. Okay, so it will give you the table in the center. Okay, now this C, serial number, actually this C stands for central alignment. If I make it L, L stands for left alignment. Now you will see the serial number has been aligned on left hand side. Okay, for ID also, let us make it L. Okay, name is also left, and let us make the rank right, so R, and let us keep this C. So serial number is on left, ID is in center, name is left aligned, and rank is right aligned. Okay, so this LCLR here, this stands for the alignment of that column. Now let us put a vertical pipe symbol here and a pipe symbol at the last. So you can see the left border and right border is there for the table. If you put this pipe symbol, right? Any doubt so far? It's students, are you getting it? Any doubts? Okay, so let us move ahead. So you are seeing the table. Now to put a horizontal line, right? Slash H line. Let us see what we get. So this is kind of experimenting. You can experiment, right? Slash H line, and at the last also slash H line. So why there is error? Because it want a line break for putting a next H line. So here initially there was no line, so it didn't need any line break. Here we already have a line break, so here we require to put a line break, and then only it will show you. So now you can see a beautiful table here, very simple, and if you don't want to put these lines between, you can do that also. Again, just like figure environment, there is slash begin table. There is table environment. This is for when you put the you want to number the tables, right? Okay, for tables mostly the caption is above the table, so slash caption table. So now you can see this is table 1. Let me remove this so that there is no confusion. So this is table 1 rank of the students. If you want to give a line break, then you can give a line break here. Okay, this is showing some error. Let me check. And again, you want to label it every time. Label table 1. So that whenever you want to give reference of this table, you can give the reference to the table. Okay. So now you have got a numbering. If you are taking this table again, so it is table 1 and it is table 2. So there is automatic numbering, right? So you can put as many as tables you want. Again, there is customization possible in the sense if you want to merge the rows, if you want to merge the columns, all of those things you can do here, right? So this is how to include the table. Now, one more thing I want to tell you that is very important, that is slash begin mini page. This is just like creating columns. Okay. So begin mini page. So I want to create a part of the page which contain 2 columns, 3 columns, and so on. So begin mini page, and I am taking it begin mini page and begin mini page, right? So suppose I am taking it 0.6 of text width. You can specify in a scaling of part scaling form also, like 10 centimeter, 20 centimeter. In that form also you can specify. But this is more easy because here, if you don't remember the exact measurements, but you just know what is the text width, then 60% is one part and 40% is another part. Okay, and I put some text or the figure here. I am taking this image sun here, and let us put some text here. So many times when you want to put something as 2 columns, so this is very useful command. There is another command also. For the same thing, you can find multiple command. Uh, you choose whichever is most comfortable for you. Okay. So this mini page command, this allows you to create 2 columns, 3 columns. Accordingly, you can create here. So this is mini page. Okay. Sometimes you have this subfigure command also. So begin figure, and you have slash subfigure. But again, it is not showing this to you because we need to use a package for this. Okay. So I will come back to this. Then we are missing the most important part, that is the referencing system, which is the soul of this LaTeX program. So how to add references and how to create the things. Okay, so let me show you. I open a file which is already there. Okay, so I'm taking a simple, this is begin the bibliography and the bibliography, right? So this is the environment for writing the references, the bibliography. Begin the bibliography and end the bibliography. And here you are seeing this is widest level. Widest level means when you are having 1 to 10, then the numbers will be aligned according to 10. If you are having 1 to 100, then numbers will be aligned like 3 digits. So the numbers for references would be aligned according to 100. Okay. So here I have given a key BIB item, that is bibliography item. And here you can define some key. Let us say tull. Okay. And then the reference. So if you do it, compile it, you will see a list of references properly numbered, properly arranged. Okay. So you are seeing that it is automatically taking references. It means the section references is not required. You simply have this. After acknowledgement, you are having references. This is again customizable, how much gap you want to give, how you want to number it. Okay. Now, how to cite this in the literature or in your document. So here you are seeing this is BIB item, and there is a key we have given to it, that is tull. Okay. So for the LaTeX here it is having a particularly defined notation for LaTeX. So for the LaTeX installation, click the link given or follow the link given in. Now I want to write 1 or I want to give the key. If I write 1 and let us say I change the position, okay, I change the position from here to here, okay. So here the numbering has changed. Earlier, which was first reference, is now 4, and my document has it 1 only. But if I put the key here, let me put the key here, /cite, and again for cite it is showing you all the citations available. It is, so you are not required to even remember it, okay. Now let us see what happens. So you are seeing it is automatically changed in the same format, actually in the better format, and however times you change the sequence of the bibliography, you are not required to recheck it in the document because it is connected with a key, okay. So this is the bibliography management of LaTeX. Now this is like a limited version because here begin the bibliography and the bibliography. If you want to make certain changes, then you have to do it manually. Manually in the sense, suppose some journal require that your bibliography should be arranged in the order of appearance in the document. Means whatever comes first should have first bibliography, first reference. So in that case, but you got it rejected from that journal, then you submitted it to another journal that says your references should be arranged in the alphabetical order as per the last name. Then what you would be doing? So you would be changing the whole reference. And it okay. So you know now understand what is the advantage of using LaTeX for the referencing system. So what I was telling is for that there is one more thing, that is NetBib. And NetBib has got its own advantages. Now you are not required to do the formatting manually. It will do the formatting for you automatically, just like all other things are being done. Okay, so how to do that? For that, first thing you need is to use the package here. /use package, and here NetBib. Okay. Again, you can customize. There are several options which you can give here. So I'm right now not going into that. So NetBib, and then you are required to create a bibliography file. So for bibliography file, first go to new, okay. Then bibliography, article in journal. Right now you can see many fields, but actually they are not at all required. In fact, I tell you, suppose we are having some research paper here, let us say uh, okay, and I say some journal, and let us say spring. Okay, so it is showing me some article with Leffler function and the truncated. So this is the article, and you can see here you are also seeing like all these commands, mathematical commands. Okay, so here what you have to do, when you go to the bottom, there is this cite the article. Another is download citation. Just a minute. I need some another journal to open this. because these days most of the journal directly provide you the citation. Share tools, download citation, and now it will ask you the format: RIS, EndNote, BibTeX, Medlars, RefWork. So I need BibTeX, so I will say download. Okay, save. When you open it, you will get the whole citation. Now whichever part you want to keep, just copy it from here and put it here. Okay, and I don't want to this abstract, I don't want this, so I have removed this. This is ePrint, URL, all these things also. If you want, you may continue, or otherwise you can remove. Right, but this underscore, this you have to put a backslash for this underscore. Okay, similarly for other articles also. So for World Scientific, it means they are giving you tools to let us go to some another articles also. In fact, from Google Scholar also, all the citations you can download in NetBib format. Okay, so when you are saying export, then export citation to BibTeX. Again, it is giving you a BibTeX citation. So here you can copy and paste in your file. Remove the things you don't want to keep. All the things you don't want to keep, you can remove. So I don't want to keep this URL and all. Okay. But there is a bit change in the format, but that doesn't affect your things. There they have used curly brackets, and there they are using this quotation mark. Okay. And there is a key. Remember, this is a key. Key should be here. No, this is at the inbook. Now file, save as. Okay, save as bib in the same folder. And as you saved it as a bib, now it is recognizing what is @inbook, what is @article. So it is recognizing everything. Okay. If there is some formatting error, then that will be you can identify only when you include it here. Okay, now so there are two references. Let me create few more in a very short form. I am doing it, okay, not in detailed form. But this feature is very important feature of LaTeX. Okay. Let us say some. So title equal to, let us put some title, then comma, then let us say author. So there are predefined fields. You are just required to use those fields. Okay, comma, then volume 2, comma, journal equal to, comma, and then close it. Okay. So let me remove this and copy this for 3-4 times. And let me change it. change the key. Okay, and save it. Now in your file, add some references in your file. NetBib you have used already. Okay. Now here at the last, you are required to give / include now the file name. Okay, that is workshop. Okay, Ankita, actually it has got some its own setting of space. LaTeX has got its own setting of space. Suppose you have a very large equation, okay, that is fitting in almost 3/4 of the page, then it will not include other things on that page. So there are few space settings which it automatically takes. So to arrange that, you are required to give the command properly and to mention the space correctly. Okay. Okay. So what I wanted to show you is, let me open it again. It is closed. Let me close these few files so that I can open it for you. Hello, is my presentation visible? Hello.
No, ma'am. Presentation is not visible.
एक मिनट let me book it again.
Yeah.
Is it visible
Now it's
now?
yes, ma'am.
Okay, thank you. So the name of bib file, that is workshop.bib. Okay, so .bib is putting is not required. /bibliography workshop, and bibliography style, there are few styles. The most standard one is APA Live, APA format that is called. So let us run it. But before that, suppose you are having 100 references in your bib file. and you have cited /cite. Now you can see that not only the citations available in your file here, see here, it is showing them, and also those available in the bib file. Let's say this is okay, and I put few more citations so that you can see, and I will remove the previous file /cite. Take another one or some. Okay, now let us see what happens. Bibliography not coming. Let me see what is the error. Not compatible with the. So I have to give a proper command. Let us replace this command by this. Use package netweb. Let us put the options also. Okay, so now it is running properly. And now you can see here, only two references I cited. One is this one, and another is this one. Okay, this was earlier our bibliography that is here. Let me remove it so that you can clearly understand. So I cited two references, and you can see two here, though my file contains more than two references. So this is one more advantage of NetBib, because these days journal asks to include only those references which are actually cited. So if your bib file contains more references and few of them are not cited, then they will not appear in your document file. So this is one more advantage of doing this. Okay, so if you make changes according to journal, then what will happen here? Instead of article, you will be having the style file of the journal, and whatever is the style file of the journal, then this NetBib package allow these references to be arranged accordingly. Okay, so this is NetBib. I will share this file so that you are not required to remember the command, and you can directly follow from this text file. Okay, so I close this file and this also. So let me open now. Let me tell you a few more things, few more commands that are available here. Now observe this package, that is use package caption, okay, and use package sub caption. So what is this package caption and sub caption? Actually, when in the document you want to place two figures or three figures side by side, then we use this command. Okay, so what is the command for that? Let's suppose you are having begin figure, okay, T, and this symbol, this shows that at the top even you can float it. Okay, then centering, that this should be centrally placed, and then begin subfigure, end subfigure, begin subfigure, in that part this is 2 inches T, include graphics, you can mention the height, width, everything, and the caption. Okay, then give some space for the next figure, then begin subfigure, next subfigure. Okay, let us see what is the outcome for this. So So you can see there are two figures side by side having sub captions and a common caption. So two sub captions and the main caption. So begin figure with caption, this is the main caption, and these two sub figures having the sub captions. So, but for these to be used, you are required to use the package caption and sub caption. These two packages are required to make this. And this star is for like numbering to be removed so that you are not required to use it again. Means like here you are seeing figure 1 though, but this figure is star, it is to remove the numbering. Now there are few more important commands. Just like you can create your own commands also. So how to create your own commands? The important part is creating the environments. These are called theorem environments, and for these the package required is AMS theorem. Because this is AMS article, so it is automatically included in this part of article. But if it is a simple article like this, then here you are required to use this command. You have AMS math, AMS fonts, AMS symbols, but then you are required to use package AMS theorem also, right? Because this is AMS article, so here it is inbuilt, okay? So now for using this command of begin theorem and theorem, where you are having theorem environments, you are required to define these commands. And how to define? This is /new theorem. This is the environment name you want to give, okay? It may be THM, or it may be THEOREM, it may be TH, as you want. But it is suggested that you use the full form, okay? This is the part which shows that how it will be displayed. So here you have to take care of whether it is a small size or in capital or in what size. So this you have to take care. In this part, this is environment name. So we are not required to take care of the capitalization or small letters. But here, what is displayed, here you are need to take care of this. And what type of numbering it should follow? It should follow the numbering type of the section. Similarly, you can define other environments. And what is the special in this environment theorem? In this environment, your caption would be displayed in bold. Okay, I show you here. There must be some theorem, then you can understand. See here, this is a theorem, right? So the caption is in bold and the text is in italics. So for this environment theorem, caption is bold and text is italics. And numbering is like section. If you want to make it subsection, you can make it subsection. If you don't give anything, it will follow like 1, 2, 3, just like the chapter. You can define corollary. Again, you can name as you want, COR, cor, or COROLLARY, corollary, whatever you like. What type of environment it should follow? It should follow the type of environment theorem. Now see where this square bracket is appearing. There are two curly brackets, then square bracket. There is one curly bracket, then square bracket, and then again curly bracket. It means this option is for numbering of this part, and this option is for this part. Okay, so corollary should follow the format of theorem, and it should be displayed like a corollary. So it is following the format of theorem, caption bold, and the text italic, right? And the numbering is also continued with the theorem. Similarly, you can define lemma, proposition. So this is by default theorem style, in which the caption is bold and the text is italic. There is another theorem style, that is, the style type is definition. Okay, we use it for definition for a standard purpose, but if you want to change it, you can do that also. So here we are having theorem style definition. For this style, we are again defining new theorem. The environment name is definition, and it will be displayed like a definition. Okay. So maybe here you can see this is the definition, because I have not given this last part here, right? Here this option I have not given, so it is taking the numbering of the chapter 1, 2, 3, 4, and so on. For with the same style, I am defining here new theorem assignment, and it will be displayed like exercise. So you're saying it is not necessary that whatever environment you define displays same. Okay. So if you are writing here assign, this is your environment name, and it will be displayed like an exercise. Here. So for this environment name I have given is assign, begin assign, end assign, and it is displayed like an exercise. Another theorem style is remark. Okay. For this I have the difference you are seeing that here the caption is bold, but the text is normal. This is theorem style definition. So for theorem style definition, caption is bold and text is normal. It means here the definition environment defined is for this style, assignment defined is for this style. Next style is remark. Okay. What happens in remark? I have given example. Okay. I have defined this example. Let us see what example style is. So here the caption is in italics and the text is normal. It means this theorem style remark defines all those environments where the caption is italics and the text is normal. So I have defined this example. Numbering should be like theorem, and it means section wise, and displays example, capital. Similarly, small remark, capital remark. So because I have not given any numbering pattern, so it will be taken 1, 2, 3, 4, like chapter wise. Okay. So this is important part again, to define the theorems and then to use them in your document. Then next important part of preamble is defining your page margins. So how to define page margins? You need to use package that is geometry. The package here is geometry. Okay. And with this package, you can define your top, bottom, left, and right margins. Okay. So if it is one-sided or two-sided, accordingly you can use the customizations also. For this, help can be found from the site I already told you, that is Stack Exchange. So top here it is 1 inch, bottom 1.5 inch, left is 0.9 inch, right is 0.7 inch. You can define in millimeters, you can define in centimeters, you can define in point also, PT. PT is for point. So there are a number of ways to use the dimensions to define the geometry of the page, that is the margins. Okay. Now, one more important thing is, I told you that for document class, you can use the options A4 paper, that is paper size, the font size, 1 column or 2 column, and then one more important option available here is R, E, Q, and O. Write R for write, EQ for equation, NO for number. So right now, if you see, the equation numbers are all on right hand side. Let us make it LEQ, NO. That is left equation number. So now you will see all the equation numbers are on left hand side. So just with a single word command, you can change the format of your whole document. Okay, let us say it two column. So A4 paper 12 point LEQNO 2 column, and your whole document will get converted into this 2 column pattern. Everything has changed. The look of all, your whole document has changed just with a single command. So that's why, and nothing has changed its positions. Okay, so I am converting it back to your standard formats, that is one column and REQ equation number, that is right side equation number. Now you are seeing few more packages here, PGF tags, arrows, right? All these things I will be discussing tomorrow when I would be talking about GeoGebra, because these commands are related to GeoGebra or creating graphics within LaTeX. So we are not creating graphics within LaTeX. That is not so simple, but it's better to create the graphics in some another software and export them in text commands within your document. So I just show you how this has been done. See, this is like, here you are seeing define color, begin tigs picture. So all these commands, this part has been imported from GeoGebra. Okay, so that we shall discuss tomorrow, how to import and export it. Okay, and here you will see directly the diagrams corresponding to this. So corresponding to these, here is the diagram you are seeing here. This picture was created in GeoGebra and exported in LaTeX. Now, final thing for today that I want to tell you is creating a resume, creating your curriculum vitae here, CV, how to do it. Now, if you know all the commands, it's very simple. I show you my resume so that you can take a glimpse. Uh, So this is created in article format. Enumerate because numbering I required. Some graphics I want to include. Long table, that is because if suppose I am having some long table, then that will not break across the pages without using this command. Okay, so we are required to use this command. Then the package geometry. Okay, then some commands you can define. Let us see what is this. So here you can see my short CV with a picture of me with my all details. There are tables created. These are sections: education, work experience, research experience. These are the sections I have created. Mini page commands I have used to put this text and the picture together. Okay. Sections without the numbering, /section star /SC education. So formatting of a document depends on your creativity, how much creative you are, in what way you want to present your data, right? So I made it a section because I want to highlight this part, and then I created a table, begin tabular, without giving any table number. Okay, just wanted to create the tabular. Then I have this work experience. Okay, then again begin tabular because I don't want any table. I want table format, but no table numbering and all. Okay, then research experience. So this is my short CV. This is just a 2-page CV. And if there are long tables, if there are long tables like this, invited lectures like this, so you can get it broken. Like here you can see this is professional affiliation and then invited lectures, right? These are in enumeration form. Then book publication, I gave it the name subsection. Then other details if you want to add as a section or subsection. I show you the bigger one also. So here for work experience, I have used this long table because I want to break it across the pages. So when I use, instead of table, I use this long table, then it automatically break itself across the pages. So here you can see, this is work experience, research experience, then research supervised. So advantage of making CV in this is that here suppose you are having your bibliography, your file, your research papers, you can directly include the bibliography. No need to type all the research papers separately. You can just create a bib file for yourself and include that bib file. In whatever way you want to arrange it, year wise or alphabetically or in any order you want to arrange it, you can do that. So this way you can create your CV. Just be creative to create it. Few commands, if you need, you can search from the internet. You can take the online help to create the, your CV. Yes. So any doubts so far? From where you want to import, Fatima? From Word file? No, this is not possible here. You would have you are required to create. You can copy data from Word or Excel, but where to put the tabbing character, where to put the line breaks, where to put the H line or like vertical columns, that all you have to decide within the LaTeX file. Okay. So such tables you cannot directly import from the Word or Excel. I told you in the first lecture itself that the LaTeX is not compatible with the MS Office, or MS Office is not compatible with the LaTeX. Okay, any other doubts? So I will share these documents to you, whatever LaTeX document I showed you today, I will share with you so that you can practice on these documents initially, and then gradually you will learn what are the commands, what is the preamble, how to use the packages one by one. As you practice, you will learn. If you think that without practice you will learn everything, you will get ready in your hands, no. Even today I need to sometime take the references, I need to sometime go back to my other files to get the commands. Because this is a drawback that you cannot always remember the commands or the syntax of writing the things. But looking at the major advantages of LaTeX, as we have seen already, that how the numbering is so easy. If you prepare such a document in Microsoft Word, you can compare now. Okay. So the advantages are superseding the disadvantages. That's why we prefer using LaTeX. In fact, if I can show you that you saw that I have prepared my resume in it. You see all these my folders are my notes, and everywhere you will find only the LaTeX files, only the LaTeX files. So lots and lots of LaTeX files. So once you start working in LaTeX, preparing a document in LaTeX, you will forget about any other software. Okay, so tomorrow we will continue with GeoGebra and how can we export the things from GeoGebra to LaTeX? How is it compatible with LaTeX? Any doubt so far? So today the attendance is very low. Why is it so? I hope some of you already knew things.
No, no. Maybe they were there. I think then they are tired from all software we are training on.
Okay.
So yes, yes. So I'll ask them to be, or we can maybe give some more break. I given 5 minutes break. Then I also thought I was also feeling tired. So I think they must be tired on the left. So so if you are done, ma'am, I want to make some announcement. Can I do this?
Yeah, sure, ma'am. Sure.
Okay, so dear students, tomorrow we will be starting from 2 p.m., right, ma'am? You want to take
Yes,
1 hour, right?
yes,
So
ma'am.
we will start. I have already informed. I am again announcing here that we will be taking starting our session tomorrow at 2 p.m. And we will also give you break. Don't worry. Okay, we will give you a break so that you can make your tea at least. Bring some biscuits and have a cup of tea with biscuits, right? So and tomorrow, please. You also open your cameras. We will have some session where we want to see you also. Okay, so be prepared in that way. It is always good to see each other, right? It is not like that okay, we are teaching, okay, okay, you don't have a webcam, Meher. It is fine. It is fine, Meher, for your honest answer. But everyone, other students, I would encourage. Okay, Meher, there is no problem if you can arrange any other phone, or you can log in for a few minutes. It is always good to see each other so that when I meet you somewhere, I should remember you, right? So if it is possible for you, I think for a few seconds we open our camera and see to each other, and then we can switch off. We will also show you tomorrow for which we asked some moment of which for which we asked photographs, passport size. Please send it today itself if you have not sent it yet. Okay, and hope you enjoy. Please submit your assignment. Don't bother for the assignment, but please submit if you are able to do that, and post the errors also via email as you are already doing that. Okay, if you are unable to post it on the classroom, I encourage you post it on the classroom your assignment. But if you are unable to do that, you can send me email. That is fine. If you are not aware how to upload it on the classroom. Okay, I have a small child. She's a very active, naughty. If I can, okay, okay, it is fine.
For
Who
few
is?
seconds.
We will also would like to see her, right? Right. Okay, Meher, you can send me the class via email. There is no problem, right? Any assignment for tomorrow? I'll let you know. Don't worry for that. I'll give you few.
I have, yes, yes. I
Yes,
have
yes.
already told you that you have to prepare a two-page document using these commands of LaTeX.
And
Okay.
please add one PNG picture of my programming, so that will be your assignment. And I would
Right.
like, yes,
Combining these two.
yes, yes. I would like to see your that assignment reading the data from that file, which I have already given to you. Please complete now. I think you all are able to now compile the .c macro in whether you are Ubuntu user or the Windows user. So please wear a new clothes tomorrow. We will see to each other. Okay, it is all we should make it as a good occasion to see and to celebrate, huh? So this is a validity, although it is online, but we have to enjoy that part also. Okay, right? So thank you very much for all being connected here. Thank you, Meher. Thank you, Bhavik. Few of students are very active, few are maybe hesitating. Fatima, you are also very good that you are managing with your small kids. Thank you, Kuldeep. Thank you, Saroj. Thank you, Ritu ma'am, for this session. Now we are closing
Yeah,
this
thank you,
section.
Kavita
Okay,
ma'am. Yeah, sure.
enjoy.
Okay.
Okay, bye
Bye.
bye. Bye bye.